Okay, the next talk will be by Carolyn Baer, now at the University of California, Berkeley.
All right, as I get set up, I'm going to do my thank yous and be nice and efficient today. So, first of all, of course, big thank you to the CogSci family that made it possible for me to be here today, all of the people associated with the awards committee, and Bob Glushko, and Pamela Samuelson. And big thank you, of course, to everyone at UBC who was part of this work, research assistants, my colleagues, my advisor, families, schools that were participating in this work, and my funders. So there we go, perfectly timed. So I want to start today with an observation, which is that our world is full of all kinds of information for us to sort through. But a major problem that we face is that the information we're given isn't perfect. So you can think about constantly changing public health recommendations. You can think about your blurry vision when you take off your glasses. We're left with a lot of kind of uncomfortable uncertainty about that all-important information. But uncertainty doesn't always need to be dealt with or avoided. You can think about the work that we do as scientists. We embrace uncertainty to help us identify those unanswered questions that help push the boundaries of human knowledge. Or more formally, we can think about theories like Bayesian rationality, where uncertainty is a critical signal for deciding how much we should trust a given piece of information. So my research investigates this key feature of uncertainty. So I study how uncertainty, rather than being something that we need to compensate for, can actually be leveraged to help make sense of the world. And then what I'll focus on today is I study how our minds represent that uncertainty in the first place. And in both parts of this research program, I take a developmental approach. So I study the ability to reason about uncertainty as it's emerging, using the presence of any developmental change to separate the kind of core properties of reasoning about uncertainty from those that are more malleable. So today I'm going to focus on one way that our minds represent uncertainty, and that is through feelings of confidence. So intuitively, confidence is that feeling that you get when you're thinking like, oh, I'm sure that I spelled that person's name right. More formally, we could use a definition like it's the subjective probability of success at some given task. So the idea there is that if you're forming a good confidence representation, you should ultimately be accurate when you feel high confidence, but you're less likely to be accurate when you feel low confidence. Okay, so now is the best part of the talk. I want to show you a video that illustrates the challenge of studying confidence, especially when we're thinking about studying it in children. There should be sound, but there are subtitles. All right, the sound was really quiet in this room. I hope online that it came out, but you get the idea that this child has spelled out the word Nutella and has very, very confidently indicated that that word was peanut butter. So we've seen these kinds of things all the time, right? These overconfident claims about our knowledge and abilities. And it's not just in kids that we see this. So if we were to determine if this child was skilled at reasoning about confidence or not, we would have to say no, because they were very confident, but ultimately wrong. So this is a pretty big problem as we're trying to understand what confidence is, because it's the influence of something we call confidence bias, or being miscalibrated. So essentially what that means is that the child needs to interpret or report on that internal signal of confidence, something that exists on kind of a continuous scale, but they need to report it on some sort of behavior, or often in research we use something like one of these 10-point scales. So this gives our participants a lot of control. They get to decide what counts as 9 confidence. But also by relying on these discrete scales, we're losing a lot of that resolution in how they're reasoning about this continuous gradient of confidence. So a major challenge that my work tackles is trying to figure out how we can separate out the understanding of that continuous scale, something we call sensitivity. How closely or precisely can you tell apart those feelings of confidence, and separate that out from the developing bias that children have in terms of reporting and interpreting that confidence. In adult samples, we can often just throw hundreds or thousands of trials at them and apply nice statistical models. Not always the best solution when it comes to working with kids, I can tell you from firsthand experience. it's not gonna be as good. So this is a big question we're trying to figure out. How do we study this confidence signal independent of bias? So here is a solution that I developed as part of my dissertation. The strategy is to modify the way that we ask children to report their confidence by forcing children to choose between two options. So, for example, here is a question where you need to evaluate which of these two groups of dots has more dots. And what I could do in a traditional confidence measure is say, okay, how sure are you in your answer? But what I'm going to do here instead is I'm going to show you another question at the same time. Now, this second question I put up probably feels a lot harder. Maybe you're tempted to count the dots. You should feel a lot less confident in your answer. And so what we can do is we can show you these two questions and ask you to compare them. Say, which one are you more sure about? Which one is your best answer? Now, what you have to do is you need to compare your confidence between these two options, and you don't need to interpret it relative to any sort of arbitrary scale. So notice we're removing that bias component of their answers in this task. But what's also really cool about this design is that we have the ability to powerfully test for individual differences in that sensitivity to confidence, kind of the same way that your optometrist does. So what we can do is we can show people questions from kind of opposite ends of this scale. One's like a really hard, really low confidence question. One's a really easy, really high confidence question. But then sometimes we can also show them questions that are much closer together and see if they can still tell the difference between those states of confidence. How sensitive are they to that continuous signal? So, does it work? What I'm going to graph here is how often children actually got those number comparison questions correct. So if there were more blue dots, did they actually say that there were more blue dots? But what I'm going to do is I'm going to separate out their answers if they said they were highly confident or if they were less confident. And remember, those are always paired, so these are going to be always equal numbers in those two bars. So overall, this is children aged 3 through 7. We're seeing a good pattern here. We're seeing that children's accuracy is higher when they indicate high confidence and lower when they indicate low confidence. So that's telling us that their confidence reports in this task are actually meaningfully mapping on to their perceived chances of success. And we're also seeing some interesting developmental change that's happening here. So in this particular study, we don't really see that differentiation until about 5 years of age. So in my dissertation, we use this measure to answer a bunch of key questions about what confidence is and how it's developing. So I'm just going to kind of quickly overview a bunch of these. I'm happy to provide more details in Q&A, or if you want to come find me afterwards, that's great as well. So first, confidence always exists in reference to some sort of other decision. So in this case, we're using these number representations and number questions that we're asking kids to do. But we also know that things like our ability to reason about numbers develops quite dramatically during this age range. So how much of this developmental effect that we're seeing is actually due to changes in our number ability versus changes unique to something like confidence sensitivity? So one thing that we can do with our measure is, because we got children to answer all of these number questions, we can simply control for their performance on those measures. So we can say, okay, our children who are highly sensitive to number, when we control for the development in their number abilities, are we still seeing that developmental effect? And yes, we are. So we're also seeing a lot of individual variability here, but we are finding that confidence sensitivity is developing as children are getting older. Another key question within this field is whether confidence is shared across the many diverse cognitive domains that we have. So we certainly experience confidence that way. Like, I can feel confident about a decision related to numbers. I can feel confident about a decision related to area or related to emotion. Which of these faces is happier? They feel similar to us, but these decisions themselves are quite different and independent from one another. So does that mean that our confidence in them is also different and more linked to the kinds of decisions we're making, or is it maybe more centralized or something like that, where there's actually kind of a common sense of confidence or domain general sense of confidence? So what we did here is we just correlated children's individual differences when they were using or reporting these confidence judgments in these 3 perceptual tasks. And in fact, we found that they were correlated. So being sensitive to confidence in a number task and being sensitive to confidence in an area task were highly correlated, as was confidence sensitivity in an emotion task. This is in 6 to 9-year-old children. We also replicated this finding in a within subjects experiment. So that helps us avoid some of the challenges of correlational work. So here what we did is we asked children to compare their confidence, just like we were doing before, but in addition to doing these within domain comparisons, where they're comparing number confidence to another number confidence question, we also asked them to compare their confidence across domains. So they have to evaluate, are you more sure about your answer to this number question or your answer about this emotion question? So these across-domain trials should be just as easy for kids to answer if they have this domain general sense of confidence, because you're just all comparing things from kind of the same system. If you don't have that domain general sense of confidence, though, it should be kind of like comparing apples to oranges. You're trying to compare like a number thing to an emotion thing, and you can't really compare 3 to happy. They're just not interchangeable in that way. So I'm going to show you here again children's kind of accuracy on these questions. And first, this is just replicating what I showed you before. So when children report high confidence, they tend to be more accurate than when they report low confidence, when they're comparing within the same domain. But what's really interesting here is we found the same thing when children were comparing across domains. So what that's telling us is that they seem to have this domain general representation of confidence that you can actually compare across different domains. So this could mean that confidence acts as a signal that allows us to compare and integrate information across cognitive domains in a way that, for example, may not require something like language. Now, the kind of last section of my dissertation started to test the boundaries of this a little bit. So some theoretical accounts propose that confidence as a form of metacognition, kind of thinking about our own minds, is actually so domain general that it also encompasses social functions in which we reason about other people's minds. So this view actually historically draws very heavily from developmental research, so we thought this would be a really important thing to test with this new measure. So what we did is we adapted a social learning task in which children have to choose between 2 teachers. And the reason we did that is because it mirrors really nicely the confidence task in which they have to choose between 2 options. And then we gave them our confidence task and looked for correlated individual differences. And we found none. We found none across 3 different studies. We manipulated a couple of different things, but there was really no relation that we could find between these. So it does seem that there are limits to this domain generality, that confidence isn't fully domain general about everything we're thinking about. And some of my ongoing work is finding, for example, that confidence in memory decisions also doesn't seem to be correlated with these kind of perceptual decisions that I've shown you. So there do seem to be some limitations we're finding. Okay, to summarize what we found then, we see these developmental trends in these separate components of confidence. So sensitivity to confidence, being able to pick apart those kind of discrete points on that confidence continuum, that becomes more precise as children are getting older. And that's independent from any changes that are happening in bias, their ability to report on their confidence, and any changes that are happening in numerical reasoning for a numerical confidence task. We're also seeing that confidence is domain general, at least across these diverse perceptual domains in childhood. And then we're also seeing, though, that there are these limits, that domain generality doesn't extend to absolutely everything. So you could think that that would be really important for developing things like training interventions, where you say, okay, we may expect that if you're training people to reason more effectively about confidence, it could extend sometimes, but not all of the time. So these insights open some really exciting new avenues for understanding uncertainty at a whole range of ages in many different cultures or different species. You could really easily take this task and make it entirely nonverbal. And they provide a new angle to approaching those long-standing questions about how confidence is represented in the mind, which can then in turn help us understand how we might use that sense of confidence to make sense of the world. So we're going to face a lot of uncertainty in our lives, and what I hope to have shown you today is that even in childhood, we have a rich sense of uncertainty to help us make sense of that world. Thank you. Perfect.
Is confidence level associated with how comfortable individuals are with uncertainty? You haven't directly measured this. Can you speculate based on your work?
Excellent. So is confidence related to kind of your discomfort with uncertainty? So I have not personally studied this. This is actually one of the questions on my like giant to-do list that I have of like, ooh, let's figure this out in the future. I think there is reason to think that that is the case, particularly when you're thinking about how you interpret or report on your confidence. So that bias question that I was talking about, if you're really uncomfortable with uncertainty, you may be biased to report higher uncertainty in general because you don't want to feel uncertain. You're going to kind of just say, no, it's okay, I'm just going to be more certain more of the time, and that's where you could really see it happening. A really interesting question, though, is whether that discomfort with uncertainty would affect this kind of sensitivity to uncertainty. And that's what we don't really know. My intuition would be no, but I'd be really curious to explore that sometime in the future.
Really nice talk. I have another, I think is going to be a speculative question for you.
Great,
which is,
I love it.
So there's all this work, so in a lot of the criminal justice systems or in courts, there's this idea, right, that confidence is not correlated with accuracy, and a lot of that has been debunked, and there's many situations where there's a high correlation between confidence and accuracy in eyewitness testimony. And you mentioned you're doing a little work with memory now, but I'm just curious how you think about that applied area and how your work or what you've been thinking about can affect how we think about eyewitness testimony and confidence in the justice system.
Yeah, another great question. I think, especially within the world of developmental research on metacognition, more broadly necessarily than just confidence, the work of Simone Getty really gets into this, kind of thinking about how can we know if we're really sure about our own memories, for example. And so we do have a collaborative project with Simone looking at memory confidence in this context and trying to understand how that's developing in general. So again, I think pulling apart these two things that I've done here, this kind of bias influence versus sensitivity, I think could be helpful in certain ways, and I think it'll take a little bit of creativity to figure out how to apply that to something like the justice system. But you could imagine that there are many different reasons that someone may be biased and that their confidence may not relate to their accuracy. Maybe they want to present themselves as being very competent and like, oh yes, like I definitely didn't make a mistake at the crime scene, because they want to kind of preserve something about their reputation, but in fact the truth relies on them getting over that. And so that's, again, another influence of this kind of bias component. And so it may be really useful to have measures like this where that bias doesn't come in. You can say, okay, I am more confident that this happened than this happened. We'd have to figure out how to do that without, influencing people's decisions. But that could provide a different kind of way of tapping into confidence and figuring out what the truth really is without having that extra factor coming in.
One more. This is not exactly a question, but I can't help remarking that scientists tend to be far more confident in their results and claims than is justified.
As someone who studies confidence, I have the utmost respect for people who are willing to admit when they are wrong. So take that as you will. Thank you.